Hi everyone, and welcome back to another tutorial. In today's tutorial, I'm going to show you how to enable SSH key-based authentication or using SSH Key-Based Login. Alright, so what is SSH? Alright, SSH is a secure shell or a secure socket shell protocol. Right? It comprises of mainly two components, right, or two applications: the SSH server as well as the SSH client. So for those of you who are familiar with Telnet, right, Telnet communicates in clear text. So SSH does the same thing, but it allows communication through a encrypted channel. Right. So what I'm going to show you today is the step-by-step guide on how to set up SSH key-based login. So a couple of things to take note. I'll show you how to generate a key pair. And then how do you copy the public key to the SSH server, turn on the SSH key-based login in the SSH server, modifying the SSH configuration. Right. So the key thing to take note here is really do not turn off password login, right, until you have tested that you can log in using the SSH key, right? And then we'll go through the auth log to look at how do you look at successful and failed login, and from there you can identify what are the IP addresses that are doing brute force attack in your environment. For those starting up, right, it can be a little bit confusing because if you're not familiar with the public and private key architecture, you might get a little bit lost in terms of where do I keep the private key and where do I keep the public key, right? So to make it simple, right, public key is like the name denotes, right? It's a key that you share with everyone. So it's not a key that like a password that you need to protect, right? It's readily available given to other people or other application that you want to communicate with. So public and private key has a lot of application. One of the most widely used previously is really in secure email communication, whereby you give your public key to anyone who wants to send you. You basically use your public key, right, to sign your email, right, and then or give your public key to anyone who you want to have a secure or encrypted communication, right? So there are a lot of use cases for public and private key, and implementing it in a SSH implementation is just one of them. Now the key thing to take note in the SSH key-based login is where you store your keys, right? So you store your private key Remember, you store your private key in the client that you want to initiate the SSH login, right? So treat your private key like any secret password, right? And you're gonna keep it safe. So you don't share your private key with anyone for any application, right? So the private key is always held by the user. And then on the server side, right, the SSH server, you copy or you paste your public key into your SSH server, right? So you store your public key into any SSH server you want to have the SSH key-based login, right? So this is really what you need to know and remember, right, in the SSH Key-Based Login implementation. Now, enough. Okay, let's hop over to the lab environment. So in this environment, we have two machines side by side. As you can see, I have a client machine running Debian, and then I have a server machine running Ubuntu. Okay, so some of the simple steps, right, to make it easier to implement is first, go into your user account in your client machine, whereby you want to initiate the SSH connection, right? By default, the keys are stored in the hidden.ssh folder, right? So let's go over to the user. So I've created a user Alice, right? As you can see in my client application. So by default, in Ubuntu or Debian environment, the user home directory is stored inside the home folder, right? So if I go over here and go to Alice, you can see that I'm in Alice directory. Let's do a pwd, right? You can see that I'm in home Alice. Right, you'll see that for the prompt I use a /w, you don't see the full path if you're in your home directory, right? So home directory or root directory is denoted by the sign, the tilde sign, right? So let's look at the hidden directory. If I do at ls-a, you will realize that by default the .ssh folder is not created. If you add the user after you install your SSH server, right? So that's something that we need to take note, because we need to create that directory to make it easier. So if I do an ID, I can see that currently my user is not in the sudo work group, right? So to add Alice into the sudo work group, let's do a sudo user mode minus add to group sudo, and followed by the username. Okay, I won't be able to do this. As you can see, I'm not in the sudo group, right? So let's exit back out to root and then issue the same command, right? So if you're in root, you don't really have to use sudo. Okay, so now if I go back to Alice, I do an ID, you can see that Alice is now in the sudo group. Let's clear this. Okay, so first step we're going to do is to generate the key pair. But before we do that, right, it's a standard or a default that most keys or all keys are stored in the .ssh folder. Since we don't have it, we're going to create a directory. Remember, it's a hidden directory because that's where you'll be storing your key, right? So once that's done, let's just make sure that it's there. Okay, you can see that SSH folder is being created and the owner is Alice. Now the reason why I highlight the owner of the folder is because if you do not change the owner to Alice, then when you are trying to log in, you might need a sudo command if you have created the folder using the root account, right? So we've created the account or the folder using Alice, so we're good. Now let's issue the command SSH keygen, right? By default, the key pair that is created is using RSA algorithm with a length of 2048. Right? If you want to create a longer key pair or a larger size key pair for better security, you can always select a higher length or bit size like 4096. But we're going to keep it simple for now. We're going to do the default key length, right? So we just need to issue the command, hit enter, right? It will prompt you where do you want to save the key pair. So by default, the tool will try and generate and save the key pair to .ssh. So we have created a folder, so we're good. This is the name of the key pair, right? So by default, it will create a ID_RSA key pair. Now, you might want to rename it for easy identification, especially if you are using different key pair for different application, right? So we're gonna name it ID demo, and then we're gonna give it a passphrase, right? So if you are going to move your private key pair around, whether you are putting it into a key management system or you are moving it among different development client or lab testing machine, you want to give it a passphrase to protect the key pair or the private key. Okay, make sure the password match. Specify the folder. Okay, so if you do not specify the folder, default it will try and save the key to the root.ssh, right, which we do not have access using the standard command. If you want to store the keychain or the key pair into the root keychain, then you need to use sudo, right, to enter the command. Okay, so now that we have created the key pair, let's just take a look at where the key pair is. As you can see, default, I was trying to save it to the root directory just now. So let's just go to home, Alice. Okay, and then let's go into .ssh. Same thing, let's do it. Okay, we can see that I've created a key. I've named it ID depth instead of demo. It's fine. But important is that you know that the owner of the file is actually Alice, right? So when we want to initiate the SSH Key-Based Login, we don't have to use sudo, right? Because the owner is Alice, which is the user. Okay, so that is how easy it is for you to create a key pair in the client machine. The private key is usually stored without any extension, and then the public key is stored with the extension .pub. Okay, so once that is done, what we need to do is to copy, right, the public key into the SSH server, right? So a quick recap, right? The public key is stored inside the SSH server, and the private key is stored in the client machine. Okay, now the first thing you want to do is to create a user, right? So in a normal production environment, you would have a user, a sudo user that you allow SSH into, right? And most of the time it is the same user name that you allow the access, right? So we're gonna quickly add a user called Alice, right? Like I said, in a normal scenario, you'll use the same user, but for the demo purposes, just to differentiate or show you a little bit of differentiation, so I'm going to create a user called Alice Server Account, right? If you're familiar with Linux naming convention, it's usually not recommended to have your username starting with a capital letter, as they are case sensitive, right? So if you use that user to create a username with a capital, right, you need to use the following switch to force that name, right? Okay, enter password. Password wrong. Okay, Alice demo account. Okay, you can keep the information blank if you want to, right? Okay, now we have created a user called Alice server account, right? So let's add that user to suitable group so that we can switch between normal user mode and privileged user mode, right? So it's always good to have an account in with a privileged permission, right? Or adding them to the suitable group and disable, default root login, or even not allowing SU to root, right? So it helps in accounting and security. So we're not going into the detail of hardening and securing your Linux or SSH, but just general good practice to create a user with a suitable permission, and then use that to do your privilege commands or configuration. Okay, so I'm going to add that, and then let's switch over to okay. Now you can see that we are in the Alice username. So if I do a who am I, you can see that I'm Alice server account. If I do a ID, I will see that I am a member of the sudo group, right? So I'm a sudo. Okay, so once that's done, similarly, let's hop over to the home directory. -A for all to see hidden folder as well, right? You can see that default there is also no .ssh folder created. So what we want to do is to create a SSH folder, right? Hidden SSH folder. Good practice is hidden where you store your keys. Now if I do a ls-al dot, I should see the SSH the hidden SSH folder created. Permission is Alice server account. Okay, so once that is done, the next is we have to create a authorized key file, right? So the authorized key file is where SSH server knows how to look for the public key, right? For SSH key-based authentication, that's where they will check whether the private key that you are using to authenticate matches with the public key, right? So only when the key pair matches using a mathematical formula, then will you be allowed to log in through SSH to the server. Now, if you are not familiar with the authorized key, right? The authorized key file is where all the public keys are stored, right, for if you're trying to access. So by default, the root account would have a .ssh hidden folder with authorized key already available. So let's take a look at that. Remember, for privileged activities, you need to use sudo /root. Okay, you can see that there is an authorized keys file already in place. You can always take a quick look. Okay, you can see that there is no public key installed for root as well at the moment, right? Which is fine because by default I've not turned on SSH key-based authentication when I provision the Linux server in the cloud, so there's no public key that has been assigned for that. Okay, but we would still see a pair of public and private key for the root. Folder itself, right? You can okay, so by default the key pair is not created for root as well, so if you are going to use root for SSH based login, you would have created a key pair. So like I said, in the standard default configuration that I did, I did not create any SSH based key-based login, so therefore no keys is being generated. Okay, so but now let's hop back to the Alice server account, right? So what we want to do now is to create the authorized key file, right? So you can always specify create this file called authorized keys file, right? So touch creates a file, okay, and you can see that it is created, right? So what you want to do is you can use any of the text editor edit the file, right? There are two ways of saving the public key into the server. The way that I usually do is really just simply display the key and then copy and paste into the authorized key file in the server. So you copy the public keys from your client machine and paste it into the authorized key in the private machine, right? So it's one whole string. Do not make any changes to the public key. One of the common thing that I tried earlier and realized is a mistake is that don't change the command, right? So in situation whereby you're creating a key pair in outside the SSH client. For example, in Windows, you don't have SSH installed. You use PuTTY or any of the SSH generate tools in other platform, and then you realize that you created a key using another username, for example, and then you decide you want to change it, right? Recommendation: never do that. Don't touch any of the strings inside the public key because you might break the integrity or authenticity of the file, and therefore the authentication might not work. Now, if you really need to change the command for administrative purposes or for consistency purposes, use the -C switch when you do the SSH key gen, right? I will show you after this, how you can do it, and you can actually specify how you want to command or give a name to the public key that you are creating. Right, so once you copy the public key into the authorized key file, right, quit, Ctrl X, save to buffer, save, right? And then now if we do a cat, see that the file is being copied here. Okay, this is the simplest way that I like to do, copy and paste. Now, if you, for whatever reason, is not having direct access to the SSH server, what you can do is to issue the following command, right? Before that, let's just delete and recreate the authorized key file, right? And then let's create the file again. Let's just make sure that the file is empty. You can see that the authorized key is empty. Now over here, you can initiate this command called SSH Copy ID, right? So you can only do this when you have not, okay, take note, when you have not turned off password authentication on the server. That's why notice and remember my diagram, right? Do not turn off password logging until you have tested the SSH Key-Based Login. Okay, so I'm going to do SSH Copy ID -I for identity, right? You can spell out the whole word if you want to, and then specify the folder where you store your private key. Okay, remember, this is the public key, which is id-temp.pub, right? So remember, do not try and copy your private key over. Okay, always remember, private key stays with you at the client side. Okay, and then followed by username, which is our head. Okay, accept the SSH key for authenticity. Okay, enter the password of Alice server account. Okay, you can see that we are logged into the Alice Debian server, right? And you will have, sorry, you have not logged in, but you have actually copied the key, right? You'll see number of keys added, 1. And then if I now take a look at the authorized key, I should see that it has helped me copy the public key for Alice into the server. Okay, so once you understand this basic concept, you can then use the key for any of the account folders in the SSH server, right? So the username is no longer that important, right, in this whole SSH key exchange process, right? It is still important for authenticity, for accountability of authentication, but I can use Alice's account to create a key for Bob, right? I just need to make sure I copy the public key into Bob's authorized key, right, inside .bobs.ssh folder, for example, right? So have a play around with it. You'll get the hang of it once you start practicing it, right? But this is all you need, right, to create the key pair, right, and then to copy the key pair into the SSH server. So once we've done that, the next thing we need to do is to turn on SSH Key-Based Login in SSH server, right? So let's just clear everything. So next what we need to do is to just go to you need to use sudo, because the SSH config file is created by root, so you need to have a privilege command, right? So the config file is usually stored in etc ssh followed by SSHD config, right? If you have not done any changes, so it's sudo nano ssh config, right, without the .d. The .d is okay. So edit the /etc sshd config file. Okay, there are actually only two things that you need to do. Okay, actually there's only one area one configuration or parameter you need to change. You just need to uncomment public key authentication to yes, right? So once you do that, you would have turned on public key authentication on the SSH server, right? So that's how easy it is to create a key pair, copy a public key, and then turn on public key authentication, right, or key-based authentication for SSH. So let's test it out. Okay. So now we can do a SSH followed by the name or the account that you are trying to log into in the server, right? So which is Alice server account, right? That's why I've created two distinctive accounts, so you know that we are now we are going to SSH into the Alice server account in the SSH server or the Ubuntu server itself, right? Followed by the IP address. So what I'm going to show you first is that we can still log in using username and password because we have not turned off password authentication. So if I key in the Alice server password, you can see that I can still log on to the Ubuntu server. Now, what you want to test, or what we want to test now, is to make sure, back into the Debian client machine, is to test the key. So the command is to issue is SSH-I, which is the identity. Now in this situation, right, you are actually going to use your private key, right? So when you are using on the client side, always remember you are using the private key. Now you're going to use the private key, right, to authenticate to the SSH server. So there's a mathematical formula behind the scene that will calculate and verify that the private key is valid, right? So you can read out on crypto, or I might do a crypto tutorial in the future, but just need to remember, use the private key for the SSH command to connect to the server, right? Followed by Alice server. Okay, this is the server account that we're going to connect to. Okay, we have entered a passphrase, so you'll prompt you for it. You can always cache the password passphrase and tweak with the configuration, but by default you will always be prompted with the passphrase. So once you enter the right passphrase, behind the scene SSH will use the private key, right, to validate that you are the right user with the privilege to connect to SSH. So if it's successful, you can see we have now connected to the Ubuntu server, right, or the SSH server in our case, right? So if I do a who am I, do an ID, right, and then if I do an IP address, you'll see that it's the 159.203.70.95, and that is our Ubuntu server IP. Okay, so once that's done, you have validated that you can connect using SSH Key-Based Login. Come back to the client by exiting the server. Next step, which is now to turn off the password login, and at the same time it's actually a good practice to turn off SSH root login, right? So you want to not use root, especially in production environment, for privileged activities, right? You use root as probably a last resort or for heavy maintenance, right? So the best practice for managing SSH server in a production environment is always creating a sudo account so that you can audit, right, the privileged commands or the activities that is carried out by a certain administrator. Okay, of course, from a lab environment perspective, you'll see my videos. Sometimes I use sudo, sometimes I don't. It depends on what account I'm in and the convenience, right, that I want to have in a lab environment. So in a lab environment, it's a lot easier, less restrictive. But in a production environment, do turn off root login and turn off password login after you have enabled SSH key-based login. Of course, the most important thing is save your key in a safe environment, make a backup, right? Enter a passphrase so that you don't lose your keys, right? Because when you lose your keys and you don't have a recovery console, you will lose the access to the SSH server. Okay, so now I'm gonna turn off password-based login. Same thing. We're gonna go to the SSH config file. Okay, couple of places to take note. Alright, first we want to turn off the root login. Okay, permit root login. Let's do no. Okay, just for validation before I turn off root login. I have not saved it yet. So let's do a if I use root login, I should still be able to do it. You can see that I can log in using root, right? So let's exit. Okay, so now we need to turn off root login. Okay, then next step, we need to turn off password authentication. Okay, that's all you need, right? So effectively, if you realize, right, there's only 3 things that you need to change, right? Turning off root login, allowing public key authentication, and turning password authentication to no, right? So effectively, for the whole SSH-based key login, and then disabling root login and password login. These are the 3 parameters you need to change in your SSHD config file. So once that is done, let's do Control X to save in Nano, yes, and then save, right? Now, it's common mistakes that we make quite frequently, especially when we are starting out with Linux, right? Always remember to restart the daemon or the service, right? So for SSH, we're gonna use sudo system start SSH daemon, right? So once that's done, first let's try and log in using root. You can see that permission is denied, right? And then let's try and SSH using Alice server account. Same thing, deny the access using username and password. We have denied root access through SSH. Okay, now one of the key things to use for troubleshooting or for identifying brute force attack is to look at the auth.log file, right? So in most Linux instance is stored in /var/log/auth.log, right? Till you need the privilege. Okay, you can see that you will see the login activities carry out, right? So the reason why it's important to have a strong password and to also turn on SSH key-based authentication is, as you can see, as my server is connected to the internet, and the minute that somebody scans the IP address of the internet and realize there's a SSH port available, you'll see there will be a lot of cybercriminal, script kiddies out there that are trying to hack the servers out there, right? So you can see that, a lot of users from various IP addresses trying to connect. I even have user 5, no idea where they came from. So from this, you can more or less realize that, there are people out there trying to be, I don't know, right? Doing something that is not right? And trying to test out various username. Could be a password guessing, could be a brute force that they are trying to do on the internet server itself. Okay, so but more importantly, what I will show you is really, if we try and log in now using the Alice private key again, right? So we're gonna use the SSH-i followed by the private key, right? And then to Alice server account. Let's try, right? Same thing. We will see. Enter the passphrase. Once it's done, what we will see here is that there will be a log to say that accepted public key for Alice server, with the RSA share. And then one thing that you realize that, hey, I'm using a private key to log in. What does the system say? Accepted public key. So remember, the server does not have your private key; it has your public key, right? So when it identifies that the key pair matches, it uses your public key as identification that you have login using the public key after the verification, right? So don't sweat too much into the detail. It's just a way the system audit or log the message, right? So once that's done, you are connected to the SSH server using key-based login, and we have now turned off root authentication as well as password authentication. So that is how easy it is to turn on and configure key-based authentication. Remember, the actual configuration, if you understand, the concept and the basic, takes about 5 to 15 minutes max, right? But it goes a long way to secure your system, because now the scan that is happening by user hotel, right, or any other brute force or password guessing that is happening, you are much or better protected by using the SSH key. Okay. So with that, that's all for my tutorial. Hope it's useful and you learn something from it. Right? And thank you very much for watching. Take care and stay safe.